Welcome to this video on mastering advanced data wrangling and exploratory data analysis. This session focuses on practical code-driven techniques to combine, transform, and analyze datasets using pandas, prioritizing structural methods over visualizations. In this video, we will explore 5 key areas: data combination, group by practices, working with pivot tables, feature engineering, and non-graphical EDA techniques for statistical discovery. When combining data, understand the difference between concatenation and merging. Use concatenation for physical stacking and merging for key-based relational lookups, similar to SQL joins. Using pd.concat, the axis parameter determines your stacking direction. Set axis to 0 to stack rows vertically, or 1 to add features horizontally, relying on index alignment. For relational joins, pd.merge is your primary tool. The how parameter controls your join type, such as inner, left, right, or outer joins. Always ensure your join keys have matching data types. The split apply combine pattern is central to the group by method. You split the data into groups, apply an aggregation function like mean or sum, and combine the results into a new summary. Follow along with this video by copying this code into your notebook to initialize our classroom practice dataset, which includes student IDs, grades, study hours, and exam scores. Test your knowledge with these 3 challenges. Calculate average exam scores by region, find mean and maximum study hours by grade, and perform a multi-column grouping on attendance. Here are the solutions for those challenges. By combining Group BY and AGG, you can create powerful, multi-metric summaries in just a single line of code. Pivot tables offer an intuitive way to reshape data into a 2D grid. The primary parameters are index, columns, values, and the aggregation function, which defaults to the mean. To build a pivot table, pass your data frame to pivot_table and specify your indices, columns, and values. Remember to handle potential missing values using FILNA. Now try these pivot table challenges. Extract the highest average score, identify the top performing region for seniors, and calculate row-wise averages. These are the solutions. Use IDX max to automatically find category labels for peak values and specify the axis for row-wise mean calculations. Feature engineering allows you to inject domain expertise into your data. By creating new features, you help analytical models better understand hidden patterns in raw data. Finally, use pd.cut for numerical binning to discretize continuous data like study hours into categorical groups. This process can significantly simplify your analysis. Ordinal encoding converts categorical text into numbers when the categories possess a natural, logical order. We achieve this by using a dictionary and the .map method to assign hierarchical weights. Nominal variables lack a natural order, so ordinal encoding should be avoided. Instead, use one-hot encoding with pd.get_dummies to create binary indicator columns for each category. Data normalization is critical when features exist on drastically different scales. Techniques like min-max scaling or standardization help ensure that all numeric features contribute equally to distance-based calculations. Exploratory data analysis can be graphical or statistical. While visual charts are standard, statistical non-graphical EDA is often preferred for being precise, easily automated, and computationally fast. Perform multi-condition filtering by combining Boolean clauses with bitwise operators. Always wrap individual conditions in parentheses to ensure correct evaluation order by Python. The query method provides a clean, readable alternative to complex Boolean brackets. By chaining it with sort_values, you can construct intuitive data narratives. For finding extremes, use NL_largest and N_smallest instead of sorting the entire dataset. These methods are computationally more efficient, especially when dealing with large datasets. To identify linear relationships, apply the correlation matrix using df.core. This returns the Pearson coefficient, helping you spot dependencies ranging from negative to positive unity. In this video, we have covered essential techniques, from dataset joining to statistical EDA. Please proceed to the practice lab to apply these steps and prepare for our next lecture on visual analysis.